Students, we are given this question: evaluate integral 0 to pi over 2 cos theta divided by 1 positive sin theta times 2 positive sin theta times d theta. So we would be approaching integration by substitution. So foremost, I would take, let 1 positive sin theta be equal to some t. Differentiating both sides, we get, it's always good to write these things down. Differential of 1 is 0. Differential of sine theta is cos theta times d theta. Of course, differential of t is dt. So when theta is 0, t is going to be 1 positive sine of 0, which is equal to 1 positive 0, which is equal to 1. So when theta is equal to 0, t is equal to 1. Now when theta is equal to pi divided by 2, t is 1 positive sine of pi over 2. Now sine 90 is equal to 1, so 1 positive 1 will be equal to 2. So when theta is equal to pi over 2, t is 2. So therefore, integral 0 to pi over 2 cos theta divided by 1 positive sine theta times 2 positive sine theta times d theta can now be rewritten as integral. The limits have changed 1 to 2. In the place of cos theta d theta, I'm going to substitute dt. In the place of 1 positive sine theta, I would be substituting t. Now I have got 2 positive sine theta. I can rewrite this as 1 positive sine theta added with 1. But 1 positive sine theta is going to be t. So this is going to be t positive 1. I'm going to rewrite this as 1 positive t. Now this denominator can be separated or can be resolved using integration by parts. I would say using partial fractions. So consider 1 over t times 1 positive t. I'm going to be taking it as a over t positive b over 1 positive t. Cross multiply. This would give me 1 is equal to a times 1 positive t positive b times t. Now I would first take let t be equal to 0. So when I take t to be equal to 0, I get 1 equal to a of 1 positive 0 positive b of 0. This would give me 1 is equal to a, or a is equal to 1. Now the next case is, let me take t to be equal to negative 1. So when I take t to be equal to negative 1, if I were to take this as say 1, therefore 1 would now be rewritten as 1 is equal to a of 1 negative 1 positive b of negative 1. This will give me a of 0, negative b is equal to 1. So therefore b is equal to negative 1. So I've got the value of a, I've got the value of b. So we can hence write, okay, therefore 1 divided by t times 1 positive t is now rewritten as 1 over t positive of negative 1 over 1 positive t. So hence integral 1 to 2 dt of t times 1 positive t is now rewritten as 1 to 2. Now 1 over t times 1 positive t is going to be 1 over t negative 1 over 1 positive t. Okay, that has to be multiplied with dt. So this is further rewritten as integral 1 to 2 dt divided by t negative integral 1 to 2 dt over 1 positive t. Now clearly this is log t. You can also use ln t. Limits being 1 to 2, negative, this is going to be log of 1 positive t, limits being 1 to 2. Now, applying limits, we get, this is going to be log of 2, upper limit, minus lower limit, log 1, negative, log of 1 positive 2 minus log of 1 positive 1. I can rewrite this as log 2. This goes away. Log 1 is 0. Negative log of 1 positive 2 is going to give me log 3. This is going to be positive log 2. I can add log 2 with log 2. So that would in turn be 2 times log 2 negative log 3. Now there is a formula. What is that formula? A times log b can be rewritten as log b raised to the power a. So because of this formula, this could be rewritten as log of 2 squared negative log 3, which is equal to log 4 negative log 3. Now there is another formula which is as follows: log of a negative log of b is equal to log of a over b. So by that formula, this is going to be log of 4 over 3. And this is the final answer to this question.